There are around 10 to the power 22 stars in the universe, and life came into existence here once and only once. Upon reflection, this statement seems a little unlikely. It's no wonder then that through the ages, humanity has wondered at the idea of alien life beyond planet Earth. Do aliens exist? Where are they? Are they like us? Would we be able to find any common ground with them, or would they be completely alien to us? What if I could tell you that I knew the answer? Before you ask, no, I've not been read into any covert Men in Black government programs that have been hiding the truth from the general population. But neither are we simply reliant on our imaginations when it comes to alien life. There is much that science can tell us through discoveries and deductive reasoning, even though I assume most of us have never met an alien in the flesh. So, are we alone in the universe? It's time to find out. I'm Alex McColgan, and you're watching Astrum, and in today's Supercut, I'm going to share with you everything I know about alien life. Everything. Men in Black be damned. When it comes to searching for alien life out there, it pays to start with a very relevant question. What do we mean by life? Life on planet Earth comes in many shapes and sizes, from the tallest trees to the smallest microbes, from spindly insects to birds or fish or humans. Our planet is teeming with life. We generally understand what we mean when we say a living thing. We might define it by it moving around or by it growing. Generally speaking, scientists define life as any system that is capable of eating, metabolizing, excreting, breathing, moving, growing, reproducing, and responding to external stimuli. Essentially, they are aware of their surroundings in some way. They seek resources. They take those resources into themselves and they use them to grow or create more of themselves. And then they get rid of any waste that's left over. Ew. Some forms of life are much more active than others, but even things like plants can move to face the sun, open their buds, or spread out their roots over time. So we look at these things and consider them living. Even on Earth though, there are some systems like viruses that push the boundary of what it means to be a living thing. Viruses are so simple that they lack the ability to reproduce by themselves or to metabolize. Instead, they get cells they infect to do that work for them. Are viruses alive? They certainly have proved devastating to other populations of living things, and we can definitely think of them that way. But it's a debate that still rages on in the scientific community. So, although there are certain qualities that are fairly universal for living things here on Earth, we must be careful about how we go about defining life. For instance, most living things on Earth make use of water to function. It carries important nutrients around our bodies and is so vital for all life on Earth that we consider the absence of water to be a serious red flag if another planet doesn't have it. But if an alien was somehow able to exist by pumping liquid methane through its body instead of water, would that stop it from being a living thing? Probably not. So let's keep an open mind, but roughly let's define life as those things that seek out resources, grow, and reproduce. Still, although it's good to keep our starting definition general, just in case, we can actually predict with some certainty what we expect to see when it comes to alien life. Scientists and science fiction writers throughout the ages may have imagined all manner of living things, from little grey men to sentient rock monsters, and even aliens made of pure energy. All of these are possible, even that last one, which may sound speculative, but renowned astrophysicist Neil deGrasse Tyson did say he wasn't opposed to the idea. But not all of these are equally likely. How do we know? It's all thanks to one simple principle. Form follows function. As you look down at your own body, even if you do not know what all of it does, you are an incredible example of optimization. You likely have 2 hands complete with fingers and opposable thumbs, ideal for grasping tools and performing fiddly, delicate operations. You have a digestive system that is capable of taking in matter, extracting nutrients, and using them to build up or repair yourself. You have legs for locomotion, a brain for thinking, a heart that will, on average, pump 2.5 billion times across your lifetime without breaking. All of these parts of your body perform specific functions and have been honed over millennia to be really good at what they do, even if you don't feel it sometimes. You are an example of form following function. Thanks to natural selection and random mutation, nature is really good at figuring out what works. When Charles Darwin was voyaging through the Galapagos Islands, he noticed that different finches had different shaped beaks. After observing them for a time, Darwin noticed that the finches with larger, more heavy-set beaks ate different types of food than finches with smaller, daintier beaks. In fact, a large beak was ideally suited to breaking open tough seeds or nuts, while the smaller beaks were more suited to getting in nooks and crannies for grabbing insects. This observation was the basis for his well-known theory of evolution. In this theory, thanks to genetic variation and competition, nature is constantly trying out new things to see what works. And there are certain things that give you an edge. Thanks to all the light that was bouncing around from our sun, organisms that evolved to take advantage of this by developing sight had a bigger advantage over organisms that did not. They could find food better, or avoid predators, or generally navigate their environment. So useful is sight that nature did not just come up with it once. We believe the eye evolved independently about 40 times over the course of life on Earth. 40 different species that previously could not see evolved eyes. This is called convergent evolution, and eyes are not the only example of it happening. Bats are not related to birds, and yet both developed wings to fly. And speaking of bats, both bats and dolphins independently evolved echolocation to help them see in environments where light was not so plentiful. Photosynthesis has arisen dozens of times. Koalas have almost identical fingerprints to humans. This happens because there are some selective pressures that are simply universal. Everything that lives needs to gain nutrients, grow, and reproduce. And as a result, like a plant bending its roots around rocks to find softer soil, nature is good at figuring out the best way of getting what it needs. Because of the prevalence of light, eyes are just a good idea. And when something works, nature sometimes comes up with it more than once. This means that on planets that are similar to our own, it's entirely possible that evolution would end up going a similar way. Although hypothetical aliens on other planets might not look exactly like us, they might look surprisingly similar. I always thought that it looked silly that so many aliens in sci-fi films were humanoid, but perhaps this is more than just a way of easing pressure on the film's costume department. Convergent evolution says this might actually happen. If it worked for us, maybe it just works generally. Any alien that made it to the stars would need to have the ability to work tools. So, fingers or something similar would be a likely addition to an alien race. Large heads filled with complex brains for analysis and problem solving would also be a benefit. The human brain is the most complex of any animals on Earth, with 86 billion neurons. It's not so unreasonable that aliens would be the same. Thanks to our brains, it became less important to keep ourselves warm with fur, as we could craft clothes for ourselves, so aliens may not be hairy or thick-skinned if they are intelligent. Of course, this kind of logic might not carry all the way, because life might not arise on a planet that's exactly the same as ours. If there are different selective pressures, different adaptations might occur. For instance, on a planet with low gravity, plants and animals would be able to grow much taller than on Earth. There would be less energy costs to lifting nutrients up through their bodies or pumping blood around if aliens use those kind of systems. While conversely, on a planet with very high gravity, you'd likely see stockier, shorter, heavier built aliens. Their bones would need to be denser to support them in heavier gravity. Or possibly they would be aquatic, as gravity is less of a problem in water. On a planet that is further out from its star than ours, there would be less light, so an alien's eyes might be bigger. Or maybe aliens on such planets would rely on things like echolocation to see what is around them. On planets with elliptical orbits, seasonal temperatures would vary much more wildly. Perhaps on such planets you'd see an increase in the ability to hibernate, or even come back from near death, such as tardigrades, and their incredible ability to return to animation after being in the harshest of environments like the depths of space. Temperature can also affect size, such as in the depths of our oceans there occurs deep sea gigantism, as large bodies can more efficiently be kept warm, while in deserts, small animals have a larger mass to surface area ratio, allowing them to disperse heat more effectively. On a planet with fewer magnetic fields, more bombarded by cosmic radiation, perhaps life would have shorter lifespans, in much the same way as around the heavily irradiated Chernobyl nuclear power plant. Dogs and other short-lived organisms thrive, while longer-lived humans suffer. In each case, form follows function. Life will adapt to suit the conditions it finds itself in. Extremeophiles are life forms that are able to live in very hostile environments. There are lots of different kinds of extremeophiles that are well adapted to different kinds of extreme conditions, like very high or very low temperatures, pressures, dryness, radiation, salinity, acidity, and heavy metals, or any combination of those extreme conditions. These organisms span the globe, inhabiting the harshest parts of our world, from sulfuric hot springs in Japan, to the Atacama Desert in Chile, to sewage treatment plants in Germany, and even a hypersaline deep lake in Antarctica. What makes extremeophiles so interesting is their unique biology. As you can imagine, living in such extreme conditions forces you to get creative. Extremeophiles' biochemistry and physiology are often modified in very clever ways to help them adapt to their harsh environments, and this makes them an astrobiological gold mine. Many extremeophile habitats on Earth are surprisingly similar to conditions on other planetary bodies. These regions on Earth are called analogues, and they can teach us a lot about where we might find life beyond our home planet. For example, the Atacama Desert in South America is a very arid environment with high salinity, high UV radiation levels, and oxidizing soil, making it quite similar to Mars. In fact, we've been studying it as an analog to Mars for years. Life has been found across the Atacama Desert, but its presence is highly patchy. In a way, this is good news. It helps scientists identify the exact factors that cause life to appear where it does, and therefore, where we might have the best chance to find it on Mars. Certain species of Haloarchaea are also being studied as exciting astrobiological models. Specifically, Halobacterium NRC1 and Halobacterium lacus profundi. They are both extremeophiles that thrive in high salinity and are great candidates for understanding potential life on Mars and Jupiter's moon Europa. Through the study of extremeophiles, we learn what is plausible for life out in the wider universe. If life can exist in certain environmental analogues here on Earth, those same sorts of environments plausibly contain life elsewhere. We also learn what's less plausible. Life here on Earth is diverse and has adapted to all sorts of niches, but there are some places even it cannot go. Bacteria, such as Methanopyrus candeleri, one of our hardest extremophiles, can survive at temperatures of 122 degrees Celsius. But putting one into thousands of degrees lava would quickly annihilate it, as the bonds that hold its chemical structures together would be torn apart by the excessive energy. While tardigrades can survive the freezing cold of space, they're not exactly mobile there. They dry out and cease all activity, and only revive when brought back into more suitable, energy-rich environments. So, if not all environments are equally likely to foster life, what sorts of conditions are the most likely for enabling a fledgling alien race to begin and thrive? And what conditions might put an end to an alien evolutionary tree before it even had a chance to start? When choosing a nursery world for alien life, just like with building a house, it's a good idea to start by establishing your non-negotiables. Some of this is fairly simple to consider. For instance, temperature. You want a nice, temperate climate, somewhere that's not too warm and not too cold. Given that temperature drops the further you are from the sun, every planetary system has a sweet spot where the temperature of a planet is likely just right. Not too hot and not too cold, similar to Goldilocks and her bowls of stolen porridge. As a rough rule of thumb, if a planet is set at the right distance from a star, it may well have a suitable temperature for aliens to set up shop. Of course, this is in no way a guarantee. After all, Venus, a planet residing in this zone, in theory should be perfect. But its choking atmosphere makes it the hottest planet in our solar system in spite of its relative distance from the Sun compared with Mercury. So it's clear, atmosphere also plays a part in all this. Essential for life on Earth, and likely useful for aliens too, is the presence of water on your prospective planet. Water comes with some surprisingly handy chemical properties. It's solvent, allowing a wide array of molecules to dissolve inside it and then be transported around an organism's body. It's important for key chemical reactions. While it's conceivably possible that alien organisms have learned to make do with less optimal liquid to form the basis of their own lifeblood, so important is water to life on Earth that we don't have a single example of an organism that's learned to make do without it. Remember, not all living things need oxygen, or sunlight, or particular kinds of foods. But everything needs water. And in all of evolutionary history, when organisms adapted themselves into every niche imaginable, not a single one figured out how to do without it. Water could well be a non-negotiable. However, sometimes a non-negotiable is simply the neighbors that live close by. So let's consider another major reason why many of the galaxy's exoplanets fall short: their neighboring stars. Our own star is known as a G-type yellow dwarf, a relatively fast-burning, short-lived sort of star, at least compared to some of the other options out there. Stars like our Sun tend to live for 10 billion years before their cores collapse and they transform into a red giant. It is stable, and that stability has been useful for the life that eventually flourished here. However, yellow dwarfs are far from common in the Milky Way. They represent only 10% of the total stars. Far more common in occurrence are the long-lived red dwarfs, which make up 75% of the stars in our galaxy and can live for around 14 trillion years, longer than our universe has existed, which means we've never seen one die, so to speak. And unfortunately for the planets orbiting them, red dwarfs come with numerous drawbacks. For starters, red dwarfs have a much closer Goldilocks zone compared to their yellow cousins. They burn less brightly, with luminosities between 10% and a measly 0.0125% that of our suns. So unless aliens live on a world shrouded in perpetual night, which sounds cold and depressing to me and will make getting energy from sunlight a bit of a challenge, an alien world would probably need to be a lot nearer to its red dwarf to compensate. This wouldn't be in and of itself a problem if it weren't for the second characteristic of red dwarfs that make them very unpleasant neighbors: their instability. Our sun is the main source of our space weather. It shoots out a frequent stream of solar winds, flares, and coronal mass ejections. However, this doesn't compare to the amount of space weather created by red dwarfs. Flares from red dwarfs can be 100 to 1,000 times more powerful than those emitted by our sun. The frequent bursts of plasma and radiation coming from red dwarfs are powerful and dangerous enough to strip away the atmosphere and even boil liquid water on planets in the habitable zone. And given how much closer planets are to their star in a red dwarf system, the odds of life getting enough time to arise before being hit with a life-sanitizing dose of X-rays is pretty slim. If you want to live on a planet around a red dwarf, you'll likely need some serious sun cream. This rules out many known exoplanets, such as astronomer favorite Kepler 186f, which some scientists hoped might be habitable. But even during periods between harsh solar weather events, there's another problem with planets around red dwarfs: their tendency to be tidally locked. Being tidally locked means that the same side of the planet always faces the star as it orbits. There is no rotation between day and night. One side of the planet is in perpetual heat and the other side in permanent shadow. Due to gravitational constraints, planets near their sun have a tendency towards being tidally locked. Just take a look at Mercury with its day that lasts 176 Earth days, or 2 Mercurian years. This lack of rotation could render most of the planet uninhabitable. You'd either face scorching, desert creating heat on the day side, or freezing ice on the night side. Even if aliens tried to live in the narrow band of twilight that would ring a tidally locked planet, liquid water might prove difficult to find. Any moisture in the air that found its way to the night side of the planet would get locked there, solidified as ice. Overall, the planet would be very dry, and even in the twilight zone, there would be no rain. But the real clincher is the low power of a magnetic field that would likely be found on a tidally locked planet. The dynamo effect that powers the magnetic field on Earth is thought to be influenced by the Coriolis effect, the rotation of the Earth imparting momentum to rising and falling liquid metal in its core. Without this rotation, such a magnetic field would be inevitably weaker, once again subjecting you to that lethal space radiation. So we can conclude that if alien life exists, it probably is going to come into being around stars much like our own due to their stability and brightness. It'll be on a world that's not too hot or too cold, probably has some liquid water, and likely is surrounded by a protective magnetic field to shield that life from deadly space radiation. We don't have to look out across the stars to find such an environment, but can actually begin our search for alien life much closer to home, here in our solar system. It may seem a little obvious, but life has birthed here once already. Could it have done so again? Well, not everywhere here is hospitable. Mercury does not tick many boxes in regards to what would be needed for life to form. It has a very tenuous atmosphere and is far too close to the sun. This combination means that temperatures on the day side rise to over 400 degrees Celsius and the night side can drop as low as minus 170 degrees Celsius. It has been discovered that Mercury was geologically active in the past, but the last eruption was thought to be 1 billion years ago. Many extinction events would have happened during Mercury's history that would most likely have prevented life from getting anywhere. There is water ice to be found in the permanently dark craters around the planet's poles, but we theorize that only liquid water can support life. Mercury seems to be a dead, inactive, and sterile planet. The next place to visit is Venus. Venus does have a rather substantial atmosphere, but the problem is that it still isn't quite far enough away from the sun to be in the Goldilocks zone, although it's kind of right on the border of it. On Venus's surface, it is even hotter than Mercury, well over 400 degrees Celsius all over the planet. This is due to the greenhouse gases in the atmosphere, carbon dioxide making up 96% of it. This heat means that water could not stay in liquid form on the surface. There is a slight possibility, however, that there could be some form of microorganisms high in the clouds of Venus that would use UV light from the sun as an energy source. The temperature and pressure high in the atmosphere is much more hospitable than on the surface, so this possibility exists. Indeed, scientists have even detected phosphine in Venus's atmosphere. Phosphine is a gas that's only produced on Earth by microorganisms in a very low oxygen environment. Either there's an unknown process on Venus that's doing a similar thing, or it's an indicator that similar microorganisms could be found there. Intriguing. We're skipping Earth for obvious reasons. Yes, life is here, but let's for now not get into the debate about whether any of it is alien, although perhaps we'll return to that idea later. Moving on, one of the best bets in the solar system is Mars. It is situated nicely in the Goldilocks zone and has an atmosphere. The big problem with Mars, though, is its lack of a magnetic field. The magnetic field on Earth prevents the solar wind from the sun stripping away the particles in the upper atmosphere. Because Mars doesn't have this, its atmosphere has been stripped of all but the heaviest molecules, meaning it now consists of 96% carbon dioxide. At one point in its history, it did have surface water, as can be evidenced by dried up rivers and lake beds. However, today that water has gone, and if there was any life on the surface, this has most likely gone too. Scientists have been keen to find evidence of life in the rocks with the Viking missions, and looking for methane in the atmosphere with the rovers currently on the planet, but they have so far found only traces of evidence. But NASA are not deterred. Finding solid evidence of life on Mars is now one of their primary objectives, so they clearly think there is still a good chance of finding something. There are a few telltale signs that life could have existed or still does on Mars. There are possible biosignatures, like methane in the atmosphere, often the byproduct of life. Scientists can't quite agree on where the quantity of methane gas comes from, and life is a definite possibility. We also have 34 meteorites which originated from Mars. These are highly valuable, as they are the only samples from Mars that we possess. A few of these meteorites even contain what looks to be fossilized bacteria, although they are much smaller formations than any terrestrial bacteria on Earth. This is not conclusive evidence, however, as even these formations can be explained by natural processes. At this point in time, there are a couple of possible places to find life on Mars. One would be about 10 meters under the surface. Water can be in liquid form this far down, and any life would be much more protected from cosmic and UV radiation. Another theory is that microorganisms could exist under the polar ice caps. Potential evidence of this could be the darkening of the spider patterns next to geysers on the poles. The darkening could be these microorganisms as they photosynthesize the sun's UV light from under the surface. With all the attention Mars is getting from the global scientific community, I would guess we will know conclusively whether or not there is life on Mars within the next 30 years. The first planet after Mars is Jupiter. Jupiter itself is not at all hospitable to life as we know it. It barely has any form of water, it doesn't have a solid surface, and the winds and convection forces on the planet would drag down any microorganisms that try to form in the tops of the cloud layer. The deeper you go into Jupiter, the more pressure and heat increases. The chances are very slim that life could exist here in these extremes. However, Jupiter has some moons where the conditions are much better. The biggest of Jupiter's moons, called the Galilean moons, are big enough to have differentiated interiors. Smaller moons and asteroids tend to just be the same throughout, like a rock, However, bigger moons will often have layers and cores. The second of Jupiter's Galilean moons, Europa, is actually one of the most likely places to find life in the whole solar system, but not on its surface. The crust of Europa looks extremely unusual with all these fault lines running all over. The crust is actually made of water ice, and beneath this ice sheet is believed to be a liquid water ocean that spans the entire moon. Evidence of this can be seen through the rotation of the crust, which is thought to have moved by up to 80 degrees, very unlikely to have happened if the crust and core were solidly attached. Another piece of evidence is something that's only just been confirmed in the old Galileo spacecraft data. Galileo actually detected water plumes or geysers shooting water far into space when it passed by the moon very closely. In 2016, the Hubble team suspected they might have imaged water plumes shooting 200 kilometers into space, and this rediscovered Galileo data has confirmed it. NASA considers the prospect of life here so intriguing, there will be a dedicated Europa Clipper mission to be launched in October 2024. The Europa Clipper will orbit Europa, passing through the water plumes, sampling the water that is ejected. We are not expecting to find fish blasted into space by these geysers, but the water samples will tell us what the conditions are like under the crust, and if there really is a possibility of life down there. Future robotic missions that aim to reach and traverse this ocean are still in the planning stages. Interestingly, while Europa is the most likely place to harbour life around Jupiter, it is not the only moon that probably has an underground liquid ocean layer. 3 out of the 4 biggest moons of Jupiter, Europa, Callisto, and Ganymede, all could have life under their surfaces. Callisto may have a water ice layer of up to 300 kilometers thick. Ganymede has at least one water ocean layer, but could also have several, all separated by sheets of ice. Ganymede is probably the second most promising moon of Jupiter, as the bottommost water layer could be touching rock. Water-rock contact could be an important factor for life to exist, as the rock provides minerals. Just consider the deep-sea ecosystems that are formed around the oceanic hydrothermal vents right here on Earth. Ganymede is already the biggest moon in the solar system, but data also suggests that its underground ocean could also be the largest. There is a European Space Agency mission underway to Ganymede right now, known as JUICE, or the Jupiter Icy Moons Explorer, which will be arriving at Jupiter in July 2031. Beyond Jupiter, there are 3 more planets and their moons. Like Jupiter, the planets are unlikely to contain life. However, some of their moons also share the same characteristics with the moons of Jupiter. Particular moons of note are Rhea, the second largest moon of Saturn, Titania, the largest moon of Uranus, Oberon, the second largest moon of Uranus, and Triton, the largest moon of Neptune. The most exciting moon with these characteristics, though, is Enceladus, a moon of Saturn. It has extremely active geysers, which spew 250 kilograms of minerals and water into space per second at over 2,000 kilometers per hour. It ejects so much material that it has formed a ring around Saturn called the E-ring. Cassini, a spacecraft that used to orbit Saturn, was able to pass through these water plumes and detected carbon, hydrogen, nitrogen, and oxygen, all key components of life. There is definitely heat being generated under the ice crust, as can be seen in this heat map. These are the tiger stripes of Enceladus. Evidence of hydrothermal activity, water, and essential chemicals means that this tiny moon could be the most likely place in the whole solar system to find life. Sadly, we are far from proving any of this. While there are some plans to return to Enceladus, these are a long way from launch, and the orbiters set to explore Jupiter's icy moons from above have not yet arrived. Actually exploring the oceans is still a very long way off. I can understand the problem though of getting a robot that deep into a moon. but it's a little disheartening to think we don't even have a timeline for such a mission. Beyond the planets and their moons, we have dwarf planets like Pluto, Eris, and Sedna. If they follow the patterns we see in the larger moons, they too could have liquid water oceans under their surface, but we are very far from being able to prove that too. There are just two more curious places to look for life in the solar system. The first is Titan, the largest moon of Saturn. It is extremely cold, and so is dismissed by some as uninhabitable. However, it is unusual from any other moon in the solar system in that it has a thick atmosphere with methane in it. In fact, the temperature is just right that liquid methane can form on the surface. The moon actually has a methane cycle similar to Earth's water cycle. There is evidence of seas, lakes, and rivers of methane and ethane on the surface of Titan. Other factors essential to life also exist there, including chemicals and minerals on the surface, plus the moon orbits mostly within Saturn's magnetic field, which means it is protected from solar and cosmic radiation. Theoretically, life forms could exist that replace water with liquid hydrocarbons. Such hypothetical creatures would take in H2 in place of O2, reacted with acetylene instead of glucose, and produce methane instead of carbon dioxide. Titan has been compared to primordial Earth. Excitingly, NASA is launching a robotic rotorcraft to Titan, set to blast off in 2028. If it flies above the methane lakes and spots something splashing around there, perhaps we'll have a definitive answer to the question of life sooner than we thought. The last place to look in the solar system for life is on comets. A long-standing theory is that life has propagated through the galaxy on the backs of comets, although it is quite an outside possibility. Numerous missions have been conducted to comets, which have studied them closely. Some of these missions, like ESA's Rosetta mission, rather surprisingly found complex organic compounds on the comet's surface. Compounds like nucleic and amino acids, which are the building blocks of DNA and life. However, none of these missions had dedicated instruments which were able to detect life, meaning we still don't know definitively if there are alien microbes to be found on comets. I should note though, that while complex organic compounds are a fascinating find, there is still a massive gulf between organic compounds and even the simplest of life forms. Scientists just don't think that a comet or an asteroid can provide the environment needed for life as we know it to develop. For instance, there's no atmosphere, no liquid water, no protection from the sun. Perhaps comets could be the universe's taxi service for alien life, but it seems unlikely that they're a place life could start. Inhospitable locations aside, there are places in the solar system where life could have formed beyond Earth, but at this stage we have no proof that life did form in any of them. Does beyond the solar system give us any more room to hope? To answer that, it's time we talked about Kepler. You may have heard many news stories about all the thousands of exoplanets that have been discovered using the Kepler telescope. As of June 2023, Kepler has confirmed the existence of 2,778 planets. Now, we have not been able to actually image exoplanets in any kind of detail. In fact, this is the clearest real image we have of an exoplanet, taken by ESO's Very Large Telescope. Which may make you question, if this is the best image of an exoplanet we have, how can we discover exoplanets, and how do we know life could be on one? To answer the first question, we have to look at how Kepler worked. Kepler was a space probe which constantly monitored about 150,000 stars in a fixed field of view using its camera. The field of view focused on a patch of sky near the constellation Cygnus. This is what Kepler could see. The data it collected was sent to Earth and analysed to see if any stars dimmed periodically. You see, the concept is that if a star's planet passed in front of Kepler's view, the star would dim. If it dimmed, for instance, once every 100 days, we could confirm that it was a planet and it takes 100 days to orbit. Kepler was really good at finding exoplanets. Before Kepler came into operation, these were the exoplanets we knew about. As you can see, most of them are many times the size of Jupiter. Since Kepler came into operation, we have discovered and confirmed the existence of thousands of exoplanets, with thousands more still unconfirmed. Remember, these are planets which have been discovered in only this patch of sky. There is still a lot more out there. Kepler's mission ended in October 2018. However, the good news is that there is a new exoplanet finding spacecraft called TESS, which came into operation a few months earlier, which covers an area in the sky 400 times larger than the Kepler mission. It is expected that during its mission, it will be able to find more than 20,000 exoplanets. In fact, based on what we've seen, scientists can hypothesize that there are more than 100 billion exoplanets in the Milky Way alone. Using other telescopes like Hubble, ESO's telescopes, the Webb, and the Nancy Grace Roman space telescopes, these exoplanets can be studied to find out their composition, particularly of their atmospheres. The way that this is done is again from the spectra of exoplanets' light. To give you an example of how this is done, imagine white light shooting through a prism, producing what is actually a blend of colors spanning from violet to red. Light from a star shooting through an atmosphere produces a similar effect, except certain bands of light are not present. This indicates there is a certain gas in the atmosphere that is absorbing the light in that wavelength, not allowing it to pass through. The dips in this image shows what Earth's spectrum looks like as sunlight passes through the atmosphere. The dips show that oxygen is present, as well as water vapor, carbon dioxide, and methane. These gases all absorb the sun's light at these wavelengths. Looking at a section of wavelengths and comparing them with other planets in the solar system, sulfur compounds can clearly be seen on Venus, and methane on Neptune is apparent. This means that as we study exoplanets in detail and determine their spectra, we can search for atmospheres that resemble our own. If it does, then the chances are that it could be a habitable world, and also that it may already harbor life. Inhabited planets, particularly those home to intelligent life, could have telltale signs of life like smog and pollution, which would be seen in a planet's spectrum. So, have any exoplanets like these been found? Well, out of the thousands of exoplanets that have been discovered, 59 of them are thought to be rocky planets that sit in the Goldilocks zone, or the habitable zone of their respective stars. Of course, this doesn't mean that they are necessarily inhabited. We'd need a lot more evidence to be able to confirm that an alien organism actually lived on one of these exoplanets for certain. But fascinatingly, there is some evidence of that starting to come in. Let's talk more about biosignatures. Biosignatures are substances, signals, or patterns that could be a sign of biological activity. This could be as obvious and direct as a fossil, or something more subtle like the composition of a planet's atmosphere. They are important because they indicate not only the potential presence of life, but also the level of its sophistication. There's no official classification system for biosignatures, but it's useful to think about them falling into three categories: gaseous, temporal, and surface signatures. Gaseous biosignatures are direct or indirect products of metabolic activity. The most common manifestation of this is the composition of the atmosphere. For example, the presence of haze could be an indirect byproduct of a methane-rich world. This could tell us that a particular planet hosts microbial life similar to what we had on Earth over 2.5 billion years ago, before the Great Oxidation Event. It's similar to the example we explored earlier of how having free oxygen in the atmosphere could be a biosignature for photosynthesizing life. Temporal biosignatures are time-bound changes that can correlate with biosphere activity. On Earth, the concentration of carbon dioxide in the atmosphere rises and falls with the seasons. Vegetation grows in the spring and decays in the autumn. This oscillation is way stronger in the northern hemisphere than the southern hemisphere because it has more landmass. In theory, we can use this kind of information to see where on an exoplanet life is most likely to be. However, nothing is so black and white. Temporal biosignatures can be caused by abiotic factors too. The concentration of methane in Earth's atmosphere, for example, changes mainly due to its interaction with water vapor in the troposphere. So even though the methane itself is from a biological origin, the temporal oscillations are dictated by abiotic factors. I personally find surface biosignatures the most interesting. Basically, every planet reflects some light from its star. Different materials on the surface of the planet will reflect different combinations of wavelengths of that light. This results in a unique reflectance spectrum for every material. Surface features like rocks, snow, water, and soil can all be deduced from a reflectance spectra. Life can also influence the reflectance spectra of a planet. This is an example of a surface biosignature. In September of 2023, just a few months ago at the time of this recording, the James Webb Space Telescope provided a tantalizing result: the detection of a gaseous biosignature in an exoplanet's atmosphere. Dimethyl sulfide is a molecule that, on Earth, is only produced by life, mostly by phytoplankton in marine environments. It was discovered by the Webb in the atmosphere of K2-18b, an exoplanet with a hydrogen-rich atmosphere that data suggests might be covered in an ocean. K2-18b is 124 light-years away from us. Scientists are not saying that this is alien life for certain. It's still possible that the dimethyl sulfide was produced by some natural process we're not familiar with. But while that's true, to me this makes the whole subject a lot more worth investigating. It's one thing to say aliens probably exist out there somewhere. It's another to say aliens exist and it's possible we might have seen them. Perhaps we should take a step back. One of the objections I've heard to the idea of discovering alien life is just how unlikely it sounds. Is there any way of exploring how often scientists expect alien life to have arisen in our galaxy? Yes. As it happens, there's maths for that. And although so far we focused on just the most basic level of life, microbes and simple organisms, some scientists have also tried to tackle the question after that. How likely is it that we'll find life that is intelligent? Once an alien race has evolved to the point where it has become intelligent, unless it came into being through some weird mechanism we don't understand, it probably did so through outcompeting its rivals and collecting resources for itself and its offspring. Civilizations made up of such creatures will most likely also have a hunger for space and resources. Whether they gain these things through clever diplomacy or aggression, it is most likely that they will want them. As we mentioned earlier, form follows function, and this applies to cultures and civilizations too. This quest for expansion and seeking more and more energy and resources led Soviet astrophysicist Nikolai Kardashev in 1964 to propose the Kardashev scale for classifying the different kinds of alien civilizations that might exist out there. He grouped civilizations into 3 kinds. Type 1 civilizations can completely utilize the energy available on their planet. We have not quite reached this point as a species, so we are roughly a 0.7 on Kardashev's scale. Type 2 completely utilize the energy available from their star, possibly by building a giant megastructure such as a Dyson sphere to capture and utilize all of its energy output. Type 3 civilizations would be able to utilize the entire energy output of its galaxy. We have seen no evidence of an alien civilization such as this one, which is for the best, as they would likely see us in the same way we see bacteria. Mildly interesting, but otherwise completely beneath their notice. Other scientists since Kardashev have proposed further additions to this scale. Type 4s that use all the energy in the universe. Type 5s that use all the energy in multiple universes. Or even the enigmatic Type Omega, capable of utilizing energy sources beyond even that, perhaps existing outside of time entirely. Such a civilization would essentially be gods. We would have no way of detecting them, because nothing in the universe would exist except in the way they wanted it to, and we would have nothing to compare their existence against. While this may seem like a bleak outlook for humanity, if we ever came across another alien race, under this theory we would almost certainly end up competing for resources in one way or another, or just getting steamrolled by a vastly higher power. There are actually other possibilities for alien development too. After all, not all humans are interested in expanding ever outwards. In fact, with the advent of internet and online cyberspace, more and more human interaction is taking place in virtual spaces. Carl Sagan proposed a model that classifies alien races based on how many unique pieces of information they collectively know. Although much harder for us to detect at a distance, and admittedly hard to measure, this way of gauging advancement does not require an alien race to infinitely expand. An intelligent race that started looking internally, or even one that spent its entire conscious time in some kind of cyberspace, could still learn more and more about itself and the universe as a whole, while taking less and less space within that universe. For the record, Carl Sagan's scale is alphabetic, where we were at about a Type J civilization, as apparently we knew 10 to the power 13 bits of unique information in 1973. While I haven't been able to find out exactly how he worked out that figure, and mention in the comments if you know, we are probably further along this scale now, 50 years on. But as a comparison, a Type Z civilization would need to know 10 to the power 31 bits, more information than exists in the whole universe, so it's unlikely that such a race exists, at least not yet. And while it's true that we have not met an alien civilization, it is comforting to know that it's entirely plausible there would be something about them that we could understand or even find relatable. Form follows function. We as humans are the beings that think and gain mastery of our world. Perhaps one day we will meet another race that does the same things we do. Rather than seeing something truly alien, it perhaps will be like looking into a mirror. I'll leave it to you to decide whether that is a comforting thought or not. To get to that level of intelligence, there are still a number of things that need to go right. And if we are to also discover them in the night sky, the odds get even less favorable. To recap, for them to even get started, they would most likely need a starter orbit. As near as we can tell, life cannot exist without energy. They would need a planet that suited them. They would likely have competed with other organisms for limited resources, thus encouraging them to adapt and progress. In time, they would need to develop problem-solving skills and intelligence as a way of gaining those resources and outcompeting their rivals. Their civilization would then have to survive without accidentally becoming extinct due to a freak meteor strike, or earthquake, or global freezing. They would also have to not destroy themselves. They would have to invest in technology, and would have to develop a level of technology that allowed them to reach out across the universe. They'd also have to have a desire to talk to any potential neighbors, as opposed to being intensely isolationist. And finally, would have to broadcast a signal out to us for long enough that we would be able to spot them. All of this is by no means certain. However, as was pointed out by astronomer and astrophysicist Frank Drake in the first SETI, or Search for Extraterrestrial Intelligence meetings in 1961, all of this could be used to calculate the probability of us finding alien life. He laid all this out in his famous Drake equation. This may look a little complicated, but it's based on a very clever and logical idea. Using the same logic that says you can figure out how many students are in a school by calculating how many students were inducted into the school at the start of each year, and then multiplying that by the number of years students studied for, Drake reasoned that the way of calculating the number of civilizations in our galaxy, whose electromagnetic emissions are detectable, could be calculated, provided you knew the rates at which those other steps happened. Let's break it down. N is the number we're looking for. How many alien races are out there for us to see or hear? This will give us an idea of the odds of finding them. R star is the rate of formation of stars suitable for the development of intelligent life, in number per year. Not all stars are very suitable for life to develop, as some are too cold or too hot, or generally too unstable. We need to know how many are being born that could support life. Fp is the fraction of those stars with planets. Ne is the number of those planets per solar system with atmospheres and material compositions suitable for life. If they're covered with lava or are completely devoid of atmosphere or water, it's unlikely that life could form there based on our own planet's example. Fl is the fraction of how many of those planets that could support life actually do support life. Fi is the fraction of planets for which that life becomes intelligent. Fc is the fraction of times that life advances enough technologically to start sending out signals of their existence. And finally, L is the length of time a civilization exists on average. If you combine all of these elements, you could accurately predict how many alien civilizations we would be able to see up in our sky right now. Of course, you might have noticed a drawback with this equation. Some of these numbers are simply not known by us. But where's the fun in not giving it a go anyway? By inputting the numbers that scientists currently believe to be most likely, and by making a few assumptions of my own along the way, we will attempt to solve the Drake equation. If you think that any of my numbers seem unreasonable, let me know in the comments below. So, with that, let's see how many alien civilizations we might reasonably expect to see out in the night sky. To begin with, we can input our values with reasonable certainty. Scientists looking at the Milky Way galaxy can accurately predict how many stars form every year, as we have many examples to draw from. Depending on who you ask, the number ranges from between 3 and 7. Let's say 5 as a conservative estimate. Fp is easy to solve too. Through recent astronomical observations by the Kepler Space Telescope, it's become apparent that planets are very common in the galaxy, with each star on average having one. So let's set this number high as well. Let's say 90%. However, the number that we currently predict is at a suitable distance from their stars, as well as having the ideal mix of elements that would produce life similar to ours, is much lower. Of the 100 billion planets in the Milky Way galaxy, perhaps as few as 300 million fit into this category. Obviously, this does not account for alien life that's significantly different from us, but let's discount them for the moment, as then this would be even harder to predict. This gives us a percentage chance of 0.3%, quite a small chance that one of the planets in a solar system is suitable for life, so 0.003 for Ne. So far, so substantiated by evidence. Here is where things get a little tricky. For the number of times that life has arisen, we only have one example to draw from: life on Earth. To date, we have not proved that life arose on Mars or Ganymede, for all the conjecture on that front. So we can take this estimate one of two ways. As near as we can tell from the fossil record, as soon as the planet cooled down enough, life came into being, which might indicate a high value for F, perhaps as high as a certainty 1. But on the other hand, from what we know, all life originated from a common ancestor, which is to say, life formed on this planet from non-biological matter exactly once, and has never risen up again since. Scientists have looked for evidence of bacteria that might have independently come into being, but so far haven't found any. This may be a coincidence, Perhaps life did arise multiple times, but the life that arose first was more advanced and so outcompeted the newly formed simple bacteria into extinction. Still, it means that life is either incredibly certain or 1,000,000 to 1. Let's go with the more pessimistic number and see where that takes us. FL equals 0.0001%. We encounter the same problem for the arising of intelligence. There are numerous examples of animals displaying forms of intelligence. Octopi can open jars and solve puzzles, and some birds and apes can use tools or even use sign language. Perhaps this proves that, given enough time, life always evolves into becoming more intelligent. However, if we want to be strict about it, we could also accurately say that all the millions of species that have existed on the Earth, only one was intelligent enough for our purposes, us. Which makes the odds seem very low for it happening. Let's once again input our 1,000,000 to 1 value for Fi, again just to be pessimistic. In terms of how many become technologically advanced enough to start communicating, I think this number is likely much higher. Although we only have one species to compare to again, it's worth noting that humans are unintentionally chatty with the universe, quite by accident. Thanks to industry and transport, we are altering the chemical composition of our atmosphere, which is something an alien race could detect. Certain molecules in our atmosphere are only there because they are man-made. We also send signals out into space thanks to our radio signals and satellites. Sometimes we even send signals out into the stars deliberately, such as the Arecibo message, which was broadcast from Earth in 1974 and contained information about human civilization and history, expressly so any aliens that heard it could learn about us. Although these signals would not travel far on the grand cosmological scale of things before becoming dispersed and indistinguishable from background radiation, we would count as a communicating race. So I'm going to predict this number as high. Let's say 70% of intelligent races reach this level. Finally, how long do civilizations survive? For this number, sadly, we do not even have a single example. We do not know how long our race will survive until we die out, by which point there will be no one left to write down the final figure. However, although there are numerous dangers that could end us as a species, ranging from meteor strikes, nuclear war, or even solar flares, the longer we are able to survive, the more likely it is that we will go on surviving. This is because once humanity spreads out, we become more and more resilient to a species-threatening catastrophe. If we are on multiple planets, a comet hitting Earth would no longer threaten the survival of our species. If we are in multiple solar systems, a solar flare would no longer be able to get all of us. Species could, in theory, reach a sort of immortality level in this way, lasting for potentially billions of years, as long as they could get out of the danger range. Let's be optimistic and use this figure. What does that give us for the Drake equation? Based on these assumptions, our answer is 0 in our galaxy. If civilizations lived for trillions of years, which is longer than the universe has existed for, we'd still be at 0 for these values. Given these odds, our chances of ever hearing from another civilization is next to non-existent. But that's just the thing with this kind of estimate. If we instead assumed that life arising was certain, and that intelligence arising was certain too, our final answer for even a 1,000-year civilization would no longer be 0. Instead, that comes to an answer of 9 in our galaxy. 9 intelligent races who might be up in the stars right now trying to communicate with us. And if races routinely do make it to functional immortality to the point where their civilizations last for billions of years, then we would see as many as 9,450,000 in our galaxy, or more. I know these are hypotheticals, but I find this very interesting. Putting the numbers through the equation makes it a bit more tangible, a bit more magical and exciting even. According to the Drake equation, the sky could be completely silent or absolutely teeming with alien life. If it is the former, then we should probably prepare ourselves for a long, lonely existence. We should learn to get along with each other, because we are all the life we are ever going to see. There will be no aliens stopping by to say hello. We also have an even greater responsibility to preserve life here on Earth, as there likely won't be any more to replace it. But if it's the latter, then space should be filled to bursting with alien races, getting discovered all the time. So where are they all? This was the question first asked by Nobel Prize winning physicist Enrico Fermi in his famous Fermi paradox. But as I'm about to show you, there are actually numerous answers to this question, ranging from the plausible to the fanciful to the worrying, that all might account for why we might not have discovered aliens yet. Let's start by addressing the elephant in the room. Maybe there's no one to see. If it was true that it's quite difficult for life to arise from non-living materials, or if it's unlikely that life would go on to become intelligent as we have done, then it's entirely possible that there would be no ships or signals in the sky simply because there are no aliens. We would be the first ones to ever make it this far. All other planets could be empty and desolate. It would then be our opportunity to spread out across the universe and discover all these empty rocks, and the only life we'd ever encounter is whatever we brought with us from Earth. While this is a perfectly reasonable possibility, there is no conclusive evidence to prove it wrong. This is not the only explanation that exists for why the sky isn't full of signals. We should also be aware that we are constrained by a surprising natural limitation. For us to discover or make contact with an alien civilization, one of two things needs to happen. Either we need to send out a message to an alien civilization and then have them send a message back to us, or the alien civilization needs to have made the first overture, messaging us directly. There are different ways of doing this. For instance, we might be sending spaceships to each other, or we may be using unmanned probes. But there are significant issues with doing anything other than sending messages. Sending a spaceship is a tricky business. At the current speeds our spaceships are capable of, it will take potentially millions of years for an astronaut to reach their destination. The Voyager 2 probe took about 49 years to even leave our heliosphere. The nearest star is 4 light years away. In other words, it would take over 81,000 years to get even there, or about 2,700 human generations. And that's assuming that we have aliens as our closest next door neighbors. Even if we make allowances for technology to improve, it takes colossal energy to accelerate an object up to light speeds. Actually, it would take more energy than exists in the universe, for reasons we won't get into here. Mass just does not like to travel at those speeds. So, unless we or our alien friends are able to come up with some kind of workaround, most likely the easiest way to communicate with other civilizations is to send them radio signals. In fairness, it's not implausible that this speed cap will one day be broken. Scientists have hypothesized some intriguing things involving moving the space around you in warp bubbles rather than by moving yourself directly. The speed of light limit only applies to movement within a local area, so if it's your local area that's moving, you're fine. We actually have examples of this in nature around black holes, which I explore in one of my other videos. But until that becomes a scientific reality, let's just go with the fact that it's much easier to call than to visit in person. It's significantly easier and cheaper to send out light or radio waves, as simple as turning on a sufficiently large light bulb. So, let's assume that this is how our first contact with aliens will occur. Even here, however, we hit a roadblock. Radio signals and light are more than capable of traveling at relativistic speeds. It's called the speed of light for a reason, after all. However, that's its limit, light speed. Just less than 300 million meters per second. No signal can go faster than that, and this in turn limits how far we are able to see through space. Any signal from us would need to travel out across space before reaching alien life, and then, even if they decide to respond immediately, their response would need to travel all the way back, if they decided to respond. Let's imagine that happens though. We only invented the radio in the mid-1890s, so we have not really been able to do this for very long. As such, we would only be able to exchange a message with aliens who lived at most 60 light years away from us. 60 years for a signal sent out in 1900 to reach the alien civilization, and 60 years for it to come back. Our galaxy is roughly 100,000 light years across, so the 60-year light bubble we could have communicated with is truly tiny. So another answer to Fermi is that perhaps we've not existed long enough for aliens to message us back. In fairness, this limitation goes away if the aliens contact us first. After all, we are now receiving light in the James Webb Telescope that has been traveling for 13 billion years, from nearly the beginning of the universe. If an alien civilization came into being around 2 billion years ago, and they've kept existing since then, that means they now have a 2 billion light-year bubble from which we could technically see them. A 10 billion year old civilization now has a 10 billion light-year bubble. But if they were 10 billion light years away and only 9 billion years old, they would be completely invisible to us. So why haven't we heard from these aliens by now? Well, this line of thought may rest on a faulty assumption, that there haven't been any signals coming in from the stars. There have been signals. Although, while it's a little speculative, perhaps we just didn't recognize them for what they were. Obviously, when it comes to alien signals, there is some ambiguity as to what exactly we are looking for. Aliens are, after all, alien. We are not quite sure what to expect from them, as they will have likely evolved in conditions different to our own, and may well have cultural outlooks that make perfect sense to them, but are completely obscure to us. Their definition of a good way to say hello to the universe might be very different from ours. Researchers looking into possible signals from other planets have to remain very open-minded about what an extraterrestrial signal might look like. But that means such signals can get confused with signals from natural sources that we simply do not understand yet. How can we tell the difference? Let's explore this with a fascinating example. In 1961, in their pursuit of evidence for the existence of alien life, which is worth noting because it opens up the possibility of confirmation bias, researchers at the Ohio State University finished work on a specialized telescope called Big Ear. It was the size of 3 football pitches and worked on a similar basis to modern-day telescopes in that it captured signals using its large mirror on one end and bounced them through smaller mirrors on the other into 2 receivers in the center, where the results were then processed. You may notice that these capture dishes are just wireframes though, not true mirrors. This is because Big Ear was a radio telescope. It wasn't trying to see with visible light. The way Big Ear worked meant that it was more limited in its motion than a telescope that could rotate in any direction. Big Ear could only tilt its primary reflector up and down, which meant that it was somewhat limited to only listening to a point in a narrow strip of space at any one time. This was cheaper and easier to design, and the designers had an idea that would let them get around Big Ear's limitations. They built Big Ear at just the right orientation so that the rotation of the planet would be what turned it left and right. With the Earth turning it one way, and with its tiltable reflector adjusting it along the other axis, you could point Big Ear towards any point in the sky if you have enough patience. Quite a clever solution. Big Ear's direction of attention would sweep around the night sky in large, circular arcs, listening out to try to spot any unusual signals that we did not have a natural explanation for. And sure enough, in 1977, Big Ear found something. On the 15th of August, a 72-second long pulse of radio waves came in that were 30 times more powerful than anything Big Ear had heard before in the background chatter of the universe. It was so out of the ordinary that the researcher who found it wrote "wow" on the computer printout when they saw it, giving it the historical name of the wow signal. It was incredibly uniform. It rose in intensity, peaked, and then dropped back down in a smooth motion, instead of the erratic fluctuations you might have expected from cosmic radiation. This indicated that whatever had made the sound was broadcasting consistently, kind of like the beam of a lighthouse sweeping out across the stars, with us turning to look at it and then turning away again. Except it wasn't consistent. Due to Big Ear's design, researchers had to wait a few minutes before the second ear of Big Ear moved to look at that particular patch of space the wow signal had come from. And when they got there, the signal had vanished. Ever since then, despite checking back in from time to time, we have never heard another wow signal come from that region of space to this day. So, what was it? A fault in the machinery of Big Ear? A passing comet that threw out a momentary burst of signals? Or an alien civilization trying to communicate? We currently don't know. Let's take a look at another candidate, the somewhat mouthier SHG B02+14A. When one of the first SETI experiments, Project Ozma, was started in 1960 by Frank Drake, it began on the basis that if alien life were to communicate with the rest of the universe, they would do so at frequency 1420 MHz. The logic behind this was that this was the frequency emitted commonly by hydrogen, one of the most widespread elements in the universe. Aliens looking to establish communication with other civilizations might use such a frequency as a sort of common ground, a wavelength that probably holds a special significance to any race. This might have been a leap of logic, but it certainly made SHG B02+14A of interest later. Because this signal, let's just call it SHG for the rest of the video for the lack of a punchier name, did indeed broadcast at this exact wavelength. SHG was spotted on 3 separate occasions in 2003, using the Arecibo telescope and the computational power of 5.2 million home computers as part of the SETI at Home initiative, a rather cool program that is sadly no longer running. SHG had no obvious explanation for its origins in nature, and it didn't appear to be interference. But it was also too weak to say for sure whether it was clearly technological or not. On top of that, its location was peculiar. It came from a spot devoid of stars up to 1,000 light years away from Earth, and although it experienced drift, it did so in a manner that made scientists suspicious. If a signal originates from a planet, then there are a few things we might reasonably infer. A signal being broadcast from a planet, either on the surface or in orbit just above it, would likely experience some Doppler shift as it alternated from moving away from us to coming towards us through the circular path it was taking in space. There would also be movements where it dropped out of view entirely as it moved behind the planet. While SHG did indeed experience fluctuation in its signal frequency, ranging from 8 to 37 Hz per second, this would only come from a planet that was rotating 40 times faster than Earth, which seemed high. It was also strange that each time the signal was spotted again, no matter where it had been when it had last been sighted, it always began at 1420 MHz. The odds of you looking at an orbiting transmitter on 3 separate occasions and each time spotting it starting off at the exact same location is incredibly slim, which is what you'd need for this to make sense. So, Although this observation pointed to it being more likely SHG was some kind of glitch in the technology, examples like this one do leave a little room for ambiguity. For an example that might be aliens or might just be a natural phenomenon, let's look at fast radio bursts. If an alien civilization were ever to be detected, it might not be intentional on their part. Powerful engines activating, or beams firing, all might release bursts of energy that give away a galactic civilization, which makes fast radio bursts, or FRBs, interesting. They are, just as the name suggests, very fast bursts of radio waves. We have detected hundreds of these strange, millisecond-long bursts across the sky. Scientists theorize that there might be thousands of them occurring every single day. They have mostly been detected outside our galaxy, but one was detected within the Milky Way in 2020, so they're not completely foreign to us. They seem to be coming from extremely powerful magnetic fields, and as of yet, scientists have no clear idea about what their origin might be. There are plenty of theories. Perhaps they are emitted by neutron stars, or maybe black holes, but there is no proof that puts any one theory over another, including that of alien technology. So we might have already received alien signals and simply didn't recognize them. There is of course a claim that takes this idea even further. Some individuals have claimed that aliens have not just sent us signals, but have visited our planet directly, and we still haven't as a species recognized it. Here, sadly, the evidence starts to get questionable. There have been so many hoaxes, faked videos filmed on grainy, shaky cams, or even genuine mistakes where natural phenomena or satellites are taken for UFOs, that many people are now a little wary of entertaining such theories. There have even supposedly been times where the US government has deliberately, subtly propagated UFO conspiracy stories to draw attention away from their real top-secret technological projects, like the stealth bomber. All in all, ascribing extraterrestrial origins to these phenomena is often factually incorrect and poor science, and because we do not understand something does not mean we should jump to the idea that it must be aliens. Still, it only has to be proven once for our entire worldview to be forever shaken. I also find it intriguing that so many governments have started seriously exploring the topic of UFOs in the last few years. In just the last year, countries like America, Japan, and Mexico have held hearings on UAPs, or unidentified anomalous phenomena, with the intention of not cynically swatting away the topic or having a good chuckle, but as a serious attempt to address an issue congressmen are claiming to be a matter of national security. Organizations like NASA are being tasked with coming up with explanations for UAPs and are seeking to collect more data on them. And so, if governments and scientists are evaluating whether there's actually some fire behind all the smoke, let's take a moment to do the same. Could it be that at least some UFOs are an alien civilization's efforts to visit us? The first UFO sighting in modern times was by an American businessman named Kenneth Arnold in 1947. As he looked out across Mount Rainier, Arnold claims he saw 9 crescent-shaped silver objects traveling at several thousand kilometers per hour through the air. He likened them to saucers skipping on water in the way that they moved. He initially thought they might be secret military jets, but later he and other witnesses of these crescent craft wondered if they might have been extraterrestrial in nature. The media picked up his turn of phrase about the saucers, and the idea of flying saucers entered the national consciousness. Before long, other people started reporting alleged UFO encounters. The US became enraptured with the idea of UFOs. However, the US military did not take this idea quite so seriously. While initially they were understandably alarmed at the report of unknown aircraft moving around in their airspace, particularly coming right after World War II, the programs they set up to investigate UFOs were eventually shut down in 1969. Project Blue Book, The last of these programs collected 12,618 UFO reports, but ultimately concluded that they were almost all misidentifications of natural phenomena or just man-made aircraft. With such a damning report to go on, the US government officially pulled funding from the project, and investigation into UFO sightings officially ceased. Partly as a result of Project Blue Book's findings, a certain degree of stigma became associated with seeing a UFO. Anyone who claimed to have done so was often ridiculed or considered crazy. It came down to a question of evidence. If aliens were real and were visiting our planet, where was the proof of their evidence? Of course, to answer that, we need to define what we would consider to be reliable proof. Let's imagine that a person came up to you and claimed that they'd seen a silver disc shoot across the sky at a speed far faster than any airplane was capable of. Would you consider a single person's account to be proof that he'd seen an alien spacecraft? Well, not necessarily. Human memory is unreliable. Even if you trust the character of the person in question enough to believe that they weren't lying to you, they might be misremembering details, or maybe had misjudged how fast the spaceship they saw was going due to some optical phenomenon. "Ah," they cry, "but I recorded it on film." You look, but unfortunately, the video they provide is grainy and only gives you a blurry glimpse of the spacecraft. Is that proof? Again, you might well be skeptical. Even if this video is not a deliberate hoax, and it's so easy to fake film these days, it could be a digital artifact or some broken pixel in the camera, and it could just be some natural or man-made phenomenon neither of you had seen before. So what would be a good proof of alien spacecraft? Ideally, for me, I would like evidence that was seen by multiple trustworthy people, the more the merrier. It would need to be recorded by multiple pieces of hardware to eliminate the risk of it being glitchy technology, and it would have to evidence characteristics that completely ruled out it being any man-made phenomenon or natural event. Best of all, it would be repeatable. If it kept occurring, it would provide more opportunities for study to rule out other causes. Which brings us to the event that started things all off again, in 2004 and the USS Nimitz. The Navy aircraft carrier was traveling through the ocean near Southern Carolina in November of that year on a routine training exercise. Another nearby vessel, called the USS Princeton, had recently received upgrades to its radar and had started noticing strange aircraft in the area. These crafts descended from 80,000 feet to 20,000 in a blistering speed, before vanishing out of sight entirely or later shooting back up again. After a few days of this, the Princeton called the Nimitz, asking them to send someone to see what was going on. Two FA-18F Super Hornet jets were scrambled. Each jet had a weapons camera, but no weapons, as this was only meant to be a training exercise. Each jet had 2 pilots on board. Upon arriving at the scene, all 4 pilots quickly spotted what they were looking for. A strange, tic-tac shaped object was moving weirdly, zipping back and forth above a frothy, boiling patch of water in the sea below them. It had no visible means of propulsion, no wings, no rotors. It was about the size of a jet and a whitish color. The object suddenly stopped its zigzag. It had seen them. It whipped around and traveled up towards the jets as if it were intending to meet them in the air, but then rapidly accelerated away, faster than anything the pilots had ever seen before. Baffled by what they'd witnessed, the pilots returned to base, only for the radio operator to inform them that they'd begun tracking the craft again, except it was now over 60 kilometers away. It had got there in under a minute of leaving the pilot's view. To be clear, we have no jet or technology that is even remotely capable of mimicking this. There is no natural phenomenon that we know of that could do this. Whatever this was, it did things human technology can't do. This was an object seen by 4 trained professional pilots on the clock who have publicly spoken on what they saw under oath, seen by aircraft cameras and modern, advanced ship-based radar from one of the most technologically advanced nations in the world. This ticks many of the boxes for good, reliable sources of evidence. This report was logged, and nothing else was initially done with it. You might just point to this being a strange story if it wasn't for this authenticated footage that we have of it, confirmed by the US government in a Freedom of Information request. To me, that's what makes this story compelling. When a lone individual sees a light in the sky, it's easy to come up with any number of explanations for what they saw, including the fact that they might be lying. But when a government unambiguously claims that the event did indeed happen and say they want to know what it was, then the event probably did occur. But the strangest thing about this was that it kept happening. The phenomenon is currently repeating. Navy and Air Force pilots were spotting strange objects in the sky so frequently, some were claiming that it was almost a daily occurrence. Many were embarrassed to mention what they'd seen, fearing ridicule. That said, it became so common that the Navy started handing out cards to be kept in Navy pilot kneeboards in their cockpits about what to do in the event of such a sighting. Between 2004 and 2021, 144 reports came in from Navy personnel of seeing unidentified objects in the sky, 80 of them being observed by multiple sensors, 11 accounts of near misses with jets, and only ever one being positively identified. Between 2021 and 2022, sensing that there might be something to all this after all, the Navy began destigmatizing reporting and started actively encouraging its pilots to record what they saw. 247 new reports came in, and an additional 119 incidents were reported to have happened in the past. Sure enough, that's almost one every other day. In total, the number of unidentified objects had risen to 510. So, what were these objects? Their natures and probably their origins varied. Some behaved like drones, with the Navy detecting radio signals coming to and from them. Only, they stayed up in the air far longer than any drone on the market was capable of doing. Some were more like aircraft, traveling in formations, exhibiting unheard of acceleration. Some could both fly and submerge underwater, seemingly at will. Some acted like balloons, albeit with unknown means of remaining up in the air, sometimes defying wind currents by remaining completely motionless or even moving against it. No doubt, of those 510, some will simply be glitches in technology. This strange triangle in the sky is thought to not really be that shape. Instead, the unique design of the night goggles is thought to be distorting the light in this apparent drone, in a similar effect to lens glare, but uniquely tailored to this technology. However, it's still concerning that the Navy does not know what these drones were doing circling a US Navy vessel while it did training exercises at night. The Navy started calling these objects UAPs, or Unidentified Aerial Phenomena, in the hopes of removing the negative connotations associated with UFOs. And this has changed again recently to Unidentified Anomalous Phenomena. And while they do not want to assume that this is alien in origin, they're also not ruling it out. They reported their findings in a congressional hearing on the 17th of May 2021, and now are regularly, and somewhat transparently, publishing reports for the general public about the ongoing investigation, provided it doesn't give away too much about classified sources or technology they are working on. Right now, they are attempting to collect as much data as possible, knowing that it will lead to better science. And that right there is the biggest shift of all. When you see the US government reaching out to the wider community to ask, what are these things we keep seeing? It certainly confirms that there is something to see. Of course, as a reminder, although it seems likely from our evaluations earlier that alien life could well exist, we have no evidence that it does, and no proof that it's here. It does raise perhaps the most important question though. A question that, as we continue searching for alien life out there, we really need to be asking. What do we do if we find it? If alien life was ever proven to exist and could come here, what would we do? If it was far away, it would be fascinating for humanity, an answer to the question of whether we are alone. But if alien life was found that was intelligent and indeed more advanced than us and knew about us and had the means to interact with us, what then? Suddenly, this all becomes a bit more real. Suddenly, we need to answer another vitally important question. What will aliens do when they find us? To begin with though, let's hold up the mirror to ourselves. We are the only instance of life arising in the universe that we know of. The great human experiment of civilization has been going on for thousands of years and has produced many different types of society: capitalist, socialist, hunter-gatherer, nomadic, and theocratical, to name just a few. If we want to understand the behavior of alien civilizations, we need to consider societies. We thus have quite a few ideas to compare when considering how aliens might behave. As we've not seen them in spite of looking, we know for a fact that either aliens do not exist or they are subtle about their existence. If they exist in our galaxy, they are not flashy. Even if aliens are visiting Earth, which is a big if, they are not making a big deal about it. They are not building massive structures that might tip us off to their existence, and they are not flying over our cities, shooting death beams or waving flags to say a friendly hello. This allows us to conclude things. Broadly speaking, let's examine two great extremes and see how they might influence alien civilization. These two extremes are altruism and aggression, love and violence. Let's start with violence. While this may be a pessimistic starting point, it is sadly one we must consider, because as human civilization has developed throughout eras, different groups of humans have almost always clashed violently. This ties into the evolutionary idea that competition always occurs when there are more organisms than there are resources. Humans are organisms, and we need resources to survive. And so, all too often, war throughout the ages has been fought over resources. Agricultural land, people, and all the labor power and industry they can produce. Gold, oil. Even when a civilization develops space travel and reaches for the stars, this issue will still likely exist. After all, we are nearly at the stars ourselves, and there certainly seems to be no shortage of violent conflict amongst us today. So, with a sample size of exactly 1, we have to at least consider the possibility that other alien races, if they exist, are the same as us, driven by a need for resources to support an ever-growing population. Of course, when it comes to societies, there are even more reasons why clashes might occur. For instance, religious or ideological differences. The Cold War was largely fought between countries that espoused different political ideologies, capitalism and communism, that threatened each other. Alien civilization might equally differ from us ideologically. In fact, it would be surprising if they didn't. And so, it's possible they might feel their ideology is threatened in some way by ours. This could lead to conflict too. This is not even to mention the fact that some cultures idolize violence itself, deeming themselves of worth only when they are winning victories, such as Viking raiders or Spartan hoplites. Others seek to build empires, recognizing it's much easier to take wealth from others than it is to build it yourself. All these reasons are perfectly plausible for an intelligent race that has mastered its planet, outcompeted other life forms there, and likely feels good about doing so. Survival feels good. We enjoy feeling strong. But if this leads to conflict, what might an alien conflict look like? Technology raises the stakes. We currently lack the technology to move objects to other solar systems, given the vast distances throughout space. Unless we intend to just throw insulting messages at each other through the void, Actual fighting cannot be achieved until we manage to solve speed of light travel, and probably something faster than that. It is possible that one day we might get around this problem, and this instantly opens a dangerous possibility. It is theoretically impossible to move something up to the speed of light because of the link between mass and energy. The more energy something has, the more mass it has, because the two are linked, and thus the more energy you need to increase its speed further. This is only noticeable at relativistic speeds, but it does mean you'd theoretically need infinite energy to move mass up to the speed of light. But if you throw an asteroid-sized object at a planet at near light speed, then all that energy gets released in one go. This kind of strike can easily wipe out all life on a planet, and the people on it wouldn't even see it coming. Any intelligent race would be very aware of the impact potential of objects such as this. For us, we only need to look at the dinosaurs. You don't need nukes or soldiers on the ground to fight an alien war, just rocks thrown really, really fast. This opens up one possible answer to the Fermi paradox. If alien civilizations exist, and any of them prove to be willing to do this, maybe the other aliens realized that it was simply safer not to communicate. Letting other races know that you are there would simply place a target on your back. After all, if you could both do this, and they wouldn't see it coming, could they really trust you not to strike first? They could see us as a risk that they are not willing to take. Known as the dark forest theory, this possible answer to the Fermi paradox says that the only aliens out there are silent simply because they don't wish to be on the possible receiving end of these kind of planet-buster weapons. Like hunters traveling cautiously through a dark forest, they are all either quiet or dead. They have been subject to this selective pressure. However, this is not the only plausible model of behavior that might still prevent us from seeing aliens. The second option is simply indifference. With billions of years of history at play, it might not be the case that we are on technological parity with all the other forms of life that might be out there. Alien life might simply be so far beyond us, they simply regard us as dispassionately as we might an ant. They might not be talking to us because we have nothing interesting to say. Why do you not talk to insects in your garden? The gap is too great. You understand what they want perfectly, and they have no hope of understanding you. Communication would be frankly pointless. That said, life is probably rare in the universe. If they desire resources and are that far beyond us, they probably wouldn't need to mine our planet specifically. We might have value as a curiosity, something to be left alone to flourish simply because they have decided that we have some value as a specimen in some kind of grand cosmic zoo. And as any zookeeper would tell you, the closer you get an enclosure to look like an animal's natural habitat, the happier that animal normally is. While they might not care about us, perhaps they do not wish to alarm us by stepping into our natural habitat. In fairness, this is a valid line of reasoning. Humanity would likely find it very distressing to learn that we are in fact not at the top of the food chain, and that our very existence depends on the mild indifference of a vastly superior alien race. Of course, if this was true, we would need to be careful. In my home, I was perfectly willing to live and let live when I found ants in my garden. When ants came into my kitchen, I quickly got out the ant killer. We would do well not to provoke them. Both of these ideas about alien behavior are bleak, so you'll be glad to know that there is one alternative to hatred and indifference. And in fact, it may prove to be the most realistic for higher levels of society: cooperation. Cooperation exists within nature. Not all life competes. Within species, packs of wolves can cooperate to achieve their goals, protecting those within the group even as they attack those outside it. There are giant supercolonies of ants that do this, working together and spanning entire countries, with each hill all considering themselves as part of the same colony. Aggressive to those outside of it, but supportive and even self-sacrificing towards those within. There are advantages to this, as we humans are well aware. We would not have gotten anywhere if we hadn't learned how to work together. Knowledge pooled allows the creation of all kinds of technology. Ironically, no one really knows how to build a computer from scratch, but there are people who know how to build a motherboard, other people who know how to build a screen, and other people that know how to mine the resources. And all these people know that the other people exist, and so can work together. Historically speaking, there is compelling evidence that as time has gone on, we humans have become better at this kind of cooperative thinking too. It used to be that groups of humans were localized into small tribes, fighting other small tribes. However, that elevated to small kingdoms, then big ones, then whole countries and alliances spanning across national borders. Following that to its natural conclusion, at some point, a nation may exist that all humans in the world feel a part of, a unified planet Earth. But why is this a more likely outcome than violence? Simply put, technology forces it. Not only do we remove barriers to communication the more advanced our communication gets, but as our ability to destroy ourselves increases, there simply isn't an alternative except learning how to get along. Other than total annihilation, of course, but that's a pretty unappealing alternative, one would hope. And so, it's possible that aliens develop the same way. If they did, how might they behave towards the universe at large? While they might still be aggressive to outsiders initially, ultimately, they may have attempted to take this to the next level, embracing new alien races as brothers and sisters, part of a great galactic whole. It's just a continuation of the trend. With potentially millions of years of history drilling the dangers of violence into them, they may actually abhor fighting, and there may be millions of aliens of many different races all cooperating peacefully under one banner. Then why don't we see them? Well, perhaps they prefer to let us learn our own historical lessons about the value of cooperation before speaking to us. An aggressive race would not benefit the galactic community as a whole, so until we learn to get along, advanced alien races might not want to share with us their ideas and technology, particularly if such toys could then be used as weapons. Perhaps they believe that we will either figure out how to get along, or else we'll wipe ourselves out. Either way, in the meantime, it is better they stay hands-off. As any parent will tell you, sometimes telling a child something is not enough for a lesson to sink in. Sometimes experience is the only effective teacher. There might be a galactic community out there just waiting to welcome us. So, what is the point I've been trying to make with all this? I hope that over the course of this exploration of alien life, you've seen that while we've not found aliens definitively, there is a high chance that alien life is out there somewhere. As such, as long as humans continue to exist, it's not just possible that it'll find us or we'll find it. It's almost certain. It could have already happened. It could happen tomorrow or a million years from now. But whenever it happens, we will be forced to make a choice about how we wish to proceed. We hope that alien life will treat us well. We hope that we can share knowledge and discoveries, and we will come to enter into an era of peace, prosperity, and mutual respect and cooperation. However, if this exploration on alien life has taught me anything, it's that much of the hunt for alien life starts by taking a look in the mirror. Aliens could be a lot like us, and the day may one day come when we are the ones flying our spacecraft down into the atmosphere of an alien world, while indigenous life forms look up at us in awe and fear. So, what will we do then? Perhaps we would do well to think carefully about that interaction, because if in that moment we decide as humanity to exploit and control, or even exterminate, then more alien eyes could be watching us from the stars and judging us for our actions. They may one day be assessing us, whether we are a species they feel they can work with, and they could be much more powerful than us. I believe that we will find living alien life one day, but if we hope for a good outcome after first contact, perhaps we need to be the kind of aliens we wish to meet. Rather than choosing violence and war, perhaps we need to consider cooperation and altruism, no matter how difficult it might be to do so, or how strange our neighbours might be to us. After all, we hope that they will do the same. If you've enjoyed listening to the soothing tone of my voice in this video, and thought it would be exactly the kind of relaxing sound you needed to fall asleep to, you're not alone. I've seen many comments about this at the end of my videos, so I decided to give you what you wanted in an even more relaxing format. So started the Astrum Sleep Space podcast. These are previous Astrum episodes that have been reformatted for a slower paced, chilled experience, one that would be perfect to fall asleep to. Because why not learn and ponder about the universe calmly as you drift off? I publish the episodes on these platforms. The links for each are in the description and pinned comment. I'd be really grateful if you could give them a listen through and do the equivalent of subscribing, as it will help with the algorithm on the respective platforms. Thousands of you have enjoyed them already, so click on the link and listen to my latest episode. I'll see you over there. Thanks for watching. Are you as convinced as me that alien life is out there? Or are you almost as certain that it's not? Let me know in the comments below. A big thanks to my patrons and members who help make videos like these possible. If you want to support the future production of Astrum videos and have your name added to this list, find the links in the description. A big thanks for making it this far. This video has seen hundreds of hours of work put in from my Astrum team, and we're really proud with what we made. If you did like it, please consider giving it a like and a share. It will help me know you want more videos like these going forward. All the best, and see you next time.